Morning, guys. Hopefully, everyone had a good weekend. Today's will be real quick. I just wanted to do a quick explanation of what I'm looking for this week. I know I talked about this last week when we were doing our review assignments, but this week I want to focus on kind of wrapping up this unit. And since we're now shifted over to a distance learning format instead of doing a typical quiz, I figured it'd be easier just to make this more of like a long-term assignment. That way you can ask questions and spend as much time on it as you need to, and that way it's a little bit more application based as opposed to just answering questions. So I spent a good chunk of my day yesterday trying to iron out all the kinks in this. I think I've got it kind of streamlined, but I want to go through this to let you know what I'm expecting, and also to give you an opportunity if there's anything that I missed or anything that I forgot, which I'm sure there was. There's a lot involved in this, so I just want to make sure everyone's on the same page. That being said, up front, take your time on this. I know it's going to seem overwhelming at first. I tried to chunk it up into bits, and I'll show you that later on. But this is something I'm expecting you to be able to work on all week, and maybe even on Tuesday if people need to wrap it up on Tuesday next week. So you got time. This isn't like today's assignment, and there's not going to be more tomorrow. So this is for the week. So if you want to take it in the steps that I recommend, you're more than welcome to. If you really just have the time today and really just want to knock it all out so you don't have to worry about it for the rest of the week, there's nothing stopping you. But don't look at this and freak out and think that you're going to fall behind because there's going to be more tomorrow. This is it for this week. Um, so as I had been alluding to last week, I wanted to kind of compile all the stuff we've been doing together to kind of look at a real world situation that utilizes all of this information. So looking at keystone species and why they're important, taking numerical data to see how populations have changed over time and see what the impact is, and then make some reflections as to why that is, why are these changes happening with the introduction or removal of the species. So the example we're going to look at is one that we did with one of the distance learnings. I don't remember if it was last week or 2 weeks ago. I think it was last week with the review. We looked at we reviewed what a keystone species was, and this is one of the examples I posted. We're going to look at the Yellowstone National Park example because that's probably the most like fundamental, like most common example people come up with when they talk about both keystone species and ecological impact on certain species in an area. So I'm going to link a video. It's very short and it does a really good job of summarizing the history of it and also the impact moving forward, and it'll help you a lot with understanding what we're going to be looking at. The examples that I took for this are examples that they mention in the video, and they explain why these things occurred. So when it comes to the reflection portion at the end of this, when you get there, if you're confused as to what we're seeing, go back to that video. That video describes what has happened. But essentially, I need to change this. So essentially, what we're going to do is I've given you 4 species to look at, which I know sounds like a lot, but it's important that you have a broad variety to understand like what the overall impact is. I tried to keep it as small as possible, but would still give you enough species to work with that you can see the overall impact on the ecosystem. So I've given you 4 species that are native to Yellowstone National Park. You've got deer, you've got gray wolves, you've got aspen trees, and you've got beavers. And what your goal is going to be is I gave you a before and after. There was a time in the park where the keystone species was not present, and that had a big impact on the types of species you could find in Yellowstone National Park. And then most recently, over the past couple decades, they've reintroduced that keystone species to the park. And you can see the changes in the populations that resulted, which is what we're going to be looking at. So for each of these species, you've got 2 sample count transects. You've got a before and an after, and you're going to see what the changes in the population. So let me not get too far ahead of myself. Let me go through the bullet points. Sorry, I don't know what this is. My voice is going out. Anyway, so you're going to look at 4 species in the park, and you're going to do what we've been doing, where you're going to take sample data. I've got transects, which I've got on a different file here, and I'll upload all these. I know this looks like a lot, but I'll explain. So here's your transect data. So this is the transect data from the deer for before the introduction of the keystone species. So there's always going to be a before and after. If you don't understand what the before and after means, just go with 1975 versus 2005, and you can see the change between those 2 years. So here's what your transects look like. They all look the same format-wise. The only difference is the number of dots and the title of the organism you're looking at. So you've got the deer one, and this is before 1975. As you can see, there were quite a bit. In order to make it more realistic, one thing I want to point out, and I put it up here, but I know a lot of people will probably miss it if I don't talk about it. In order to make it more realistic, obviously I can't fit like hundreds and hundreds of dots on this page without losing my mind and without making you guys lose your mind because you'd have to count them all. So in order to make it simple, just treat every dot as 10 deer. So count up your dots and then just multiply that number by 10. Then to do your sample count, you've done these before, but if you're still confused, all you have to do is once you get that number, you're going to find the area of each transect. Each transect has the same area, which would make, again, that's standard. So once you do this math the first time, that's all you need. So the width of each transect is 11.5 miles. The length is 56.25. All you need to do is count the number of dots in here, multiply that number by 10 to get your total. So let's say there's 30 dots in here. That's not necessarily the right answer, but I'm just saying for the sake of example. So let's say there's 30 dots in here. If I multiply that by 10, that'd mean there are roughly 300 deer in that transect. I just take 300, and then I use that information to find the estimated density. So let me go back to the thing so I can finish explaining it. So you're gonna take your sample counts. You're gonna estimate population density, which again, all you do is you take the number that you counted and divide that by the area of the transect. So again, if it was 30, you have 300 deer, it's going to be 300 deer over whatever the area of that transect is. You're going to estimate population densities for these counts and extrapolate that data to get the estimated total. So again, you're going to get the density of the transect, so then you can apply that to the entire park, because again, it would be really tedious for researchers to go through the entire park and count anything or everything. That's the purpose of what this is for. So once you get that estimated population density, you're going to get the population density of this one and this one. Take the average of those three to get your average population density and multiply that by the total area of the park, which is 3,471 miles squared. That's a real number. I looked that up if Google's not lying to me. And that will give you an estimate for like, this is how many deer are in the park. This is how many wolves are in the park. This is how many beavers are in the park. That way you don't have to spend all day counting actual individual numbers, and I don't have to spend my whole weekend trying to make 5,000 deer dots and 200 beaver dots for each transect. It'd be way too tedious. I know I'm kind of going through this quick, but there's a lot to cover, and it's stuff we've done before, but let me know if you've got questions. I'm expecting a lot of questions this week, and I've got time. And again, you've got all week to work on this, so feel free to shoot me your questions. Once you're done taking your data and you've got your estimates, so you've estimated how many deer were in the park before 1975, how many deer were in the park after 2005, what is the change? You won't have to calculate the rate this time. You're just going to look and compare, like, okay, there were more deer in this year than this year, or there were less deer, blah, 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 whatever. So you'll have numerical data and say, like, here, I can see physically what is the difference between the populations between these 2 years. Once you have that information, just write a really brief conclusion describing like why that change occurred. It doesn't have to be like a full-blown paper. I'm not asking you to do that. I know this is already a lot with the data sampling. Really, a paragraph will be fine. Anything that will answer these questions thoroughly. Don't just like put very simple responses. Try to explain as best you can, but a paragraph should suffice. So just explain these things to me. So first of all, what is the keystone species? That one should be fairly obvious, hopefully, if you watched the video and if you read the article last week. But I didn't give it to you here because I wanted to make sure you were paying attention. Describe the events of Yellowstone, or that took place in Yellowstone National Park, meaning like basically what they describe in the video. Why did this change occur? Why do we see these changes in the populations? Why are certain species growing? Why are certain species being repressed? Why are these changes happening? What caused this to occur? Using your data, explain the effects of the introduction of the keystone species. Again, that's kind of related if you want to transition from 2 to 3. So basically, like once they reintroduced the species, why did we see a decline in this species, or why did we see an increase in this species? Why are these changes occurring? And then define a niche and describe how the niches of the ecosystem were changed. Again, that kind of relates to the last 3. So when this species was introduced, that opened up a new niche because there were new flowers that could become pollinated, so that it introduced more pollinators, or that decreased the amount of water runoff, so it increased the water quality, so that led to the development of new fish species or something like that. You get the idea if you know what a niche is. Again, if you have questions, let me know. So I know that's a lot. In order to kind of make this a little bit more condensed and less overwhelming, I made a timeline that I think would work best. If you want to do this in chunks, again, if you want to do it in bigger chunks, if you want to get this all done right away, that's perfectly fine, but I don't know that many people are going to do that. Day 1, first thing, just watch the introductory video, make sure you understand the point of the assignment, and then try to take your sample counts for the before data, or if you'd rather do it, because I kind of grouped them up based on species, if you want to do like the before and after for deer and wolves, basically do half of your sample count. So either if that's all the before, all the after, or if you want to do 2 species, so the before and after for deer, before and after for wolves, then cut it off, whatever it may be. I would try to get at least half your sample counts done. It sounds like a lot of work, but once you get the hang of it, it should hopefully not take that long. I did all the calculations myself just to make sure, um, A, they were right, but also to make sure it wouldn't take too long. Um, so all you have to do is count these dots in the boxes, divide by the area, do that 3 times, put it in your chart, and then move on. I don't expect it to take that long. I tried not to make this a really tedious and time-consuming assignment, but let me know if you're having issues with it. Day 2, if you didn't finish your sample counts from the first day, go ahead and finish those. So basically today and tomorrow we'll just be working on the math side of it. So you've got today and tomorrow to get your counts, get your estimates, try to estimate the total population, make sure everything makes sense. Thursday, day 3, I would try to have all your data collected, and that would be the day that I would try and spend on wrapping stuff up and reflecting, making sure that everything is filled out nice and neat, make sure you've got all your work done, make sure you've got your tables filled out, and then write your paragraph, write your reflection saying, here's what we saw, here's why this happened. Make sure you answer those 4 questions. I left an open day just in case there were questions, because again, since this is a longer assignment, and it's covering some stuff that's a little bit more mathy and some stuff that I know some people had issues with as we were going through it. So I wanted to give lots of time for you guys to ask questions if you had it. So I'm gonna open it up to Tuesday. We'll probably spend Tuesday just wrapping up. Hopefully, most people will be done by then. But if that's not the case, I left that just so we can be flexible, just in case we need more time. But that's really it. I try to keep it nice and simple, both for the sake of time and considering this is over distance learning. So here's where you'll put your work. I tried to do a Google form, or not a Google form, a Google Doc this time after the recommendation from a couple people last week. Hopefully it didn't mess stuff up. So here's what you're going to do. A couple things I need. I need the area of each transect. You only have to calculate that once, like I said, because each area or each transect is the same. So just multiply length times width. Get the area, plug that in here. You'll use that for every calculation for every transect. And then area of the whole park I put on here. You don't even have to calculate that. You don't have to look that up. It's right here. I just put that there so I know that you know what the whole area is, because again, that's how you're going to get your estimated totals. So just put that there, and that way you can always reference back to that. You got before and after sample counts. I know these look like a lot, but again, once you get going, they'll make sense and they'll go pretty quick, hopefully. So, oh, I need to change. Oh no, I don't. I just skipped one. So you got your deer transect before. Try and keep track of these. I know there's a lot. I tried to make them as distinct as possible. I highlighted a couple words, but make sure you're typing in the right box. They start to blend together after a while. I had to be very diligent last night when I was working on these. So deer transect before, if you go to your data, so I'm going to do my sample counts, I'm going to count these up. So let's, again, going back to my example, let's say I counted 30 in the first box, so I'll put 30 in this box. Let's say there's 15 in the second box, 15 and 12, and I'll put that in the third box. So that's going to be your data here. That just tells me, because again, depending on what you count as in the box versus out of the box, some people will get different numbers. I know a lot of people had questions last week. So not everyone will get exactly the right number, but there should be like a range where it should be close. Estimated population density, again, all you're doing for that information is you're going to take the sample count that you got here, so again, whatever this is, 30, 15, 12, divide that by the area. Your area is up here. To get your number here, it should be a decimal. It should be a percentage, so it's like a percentage per square mile. And then you're going to use that to get the average population density. These should be all the same. Take your 3 population densities for the 3 transects, add them together, divide by 3, and then get your average. And then the very last thing you're going to do is take that average population density, multiply that by the area of the whole park, and that will give you your estimated total. So this will say, like, you'll get a fairly solid number, and it'll say like this: there are 686 deer in the park, or there are 1,115 deer in the park. You'll get some big number, and that'll be your estimate for how many would there be in the total area. We've all done this before, but again, I want to be thorough just to make sure everyone understands, and feel free to shoot me emails if you're confused. And as always, join the Zoom call on Thursday if you're really struggling, or maybe I could set up an extra one this week since there's a lot involved here. But we had some good questions last week, so don't feel afraid to ask any questions. But if you understand that, the rest of these play out exactly the same. Look at your deer after transect, take your sample counts, estimate the population density, get your total, then do the wolves before and after, aspen trees before and after, and beavers before and after to get your estimated totals. And then answer your questions. So I think that's really it. I tried to be as thorough as possible. Um, I try to keep it as simple as possible. Hopefully this isn't overwhelming. I don't want to overwhelm you guys at home, but I do want to make sure that you guys understand this thing we've been doing for the past couple weeks. So do your best to try and get started today. If it's just completely confusing and you don't understand, just shoot me an email. I'll try to answer it as best I can, and I'll try to work through it with you as best I can, and we'll take it from there. So yeah, either way, shoot me questions if you have them. And again, you've got the whole week to work on this. This is the only thing we're doing. I'm not going to post anything new tomorrow unless it's an addendum to this, if I made a mistake or if I need to add another resource, um, whatever it may be. So this is it. This is what you're working on. So get what you can done today. If you want to get all of it done today, you're more than welcome to. At the very least, try to get at least one, or try to get half your sample counts done, and then you can do your math and the rest of the sample counts tomorrow. Whatever works for you. Either way, I'll stop talking because I think I've said it all at this point. So let me know if you have questions, and have a good week.